Okay, we've just seen that the way to rank 20 out of 100, the number of ways to rank 20 out of 100 in order, obviously, if you're ranking them, is to divide 100 factorial by 80 factorial, which is equal to this expression. And of course, this is what the fundamental counting principle would tell us. And that could be written as 100 factorial over 100 factorial over 100 minus 20 factorial. Okay, the 80 is related to the numbers 20 and 100 in the obvious way. It's 100 minus 20 because you got to get rid of everything beyond the first 20. And if we make these choices unordered, we have the same expression, but divided by also 20 factorial. So here's the expression. Now, in general, we can take this insight and use it to write a couple of formulas. The number of ways to choose R objects from N. Now, a minute ago, we just chose 20 from 100. And that's in order, okay, is what? Well, we said it was 100 factorial over 100 minus 20 factorial. We understood why those numbers were what they are. Well, if the numbers instead of 120 are N and R, then we have N factorial over N minus R quantity factorial. Now, and let me make sure you understand that there's no distributive law here. This is not equal to N factorial minus R factorial. Big difference. You can't make that mistake. Okay, there's you have a distributive property for multiplication over addition, and it's good that you have some sort of an instinct that there is such a thing as a distributive property, but it applies to multiplication over addition. It does not apply to exclamation points. Okay, well, so we have N factorial over N minus R factorial, just like our 100 factorial over 100 minus 20 factorial, which is 100 factorial over 80 factorial, the number of ways of choosing 20 out of 100. We use a couple of possible notations for this. One is subscript N P R is equal to N factorial over N minus R factorial. Now the P and another notation is P of NR is the number of permutations. Of R objects. I'll say when R objects are chosen from N objects. Okay, and the word there is permutations. I'm not going to make a similar statement here. I could, but if order doesn't matter, what do? We divide by the number of ways that R objects could be ordered, and that number is R factorial. That gives us what? Well, our previous expression, the number of ordered choices is N factorial over N minus R factorial. Here we got it. We divide that by R factorial. We rearrange it. We have N factorial divided by R factorial times N minus R factorial. And we give that a name. That's NCR. And that could be also C of NR. Okay, but NCR is just that N factorial over R factorial times N minus R factorial. C stands for combinations. So this is a number of unordered selections. If we have 20 out of 100 unordered, then it's 100 factorial over 20 factorial times 100 minus 20 factorial. That would be your 80 factorial. So the NCR or C of NR is the number of combinations. Now, a lot of section 3 in your text is about permutations and combinations. You have to decide whether a given situation is a given set of selections needs to be in order, or whether order doesn't matter. If order matters, we're going to use the permutations. If order doesn't matter, we use the combinations for reasons that I hope you understand at this point.